Hello everyone. Sorry for the delay between my car problems starting the car up and the issues getting Facebook to work out here. I'm sorry for starting a few minutes late here. So welcome to the Stockton University Natural Sciences and Mathematics School. We're doing live streaming of events. Today we're doing some events looking at the fossils here that most of you probably don't necessarily realize are present here in New Jersey. So today we are up here in Holmdel Township. I'm going to flip the camera around so that you can see. Over there is the Holmdel School District. The village school is right there. That is actually the easiest place to park. You can actually see my car there. But where we are today is we are at the Reminiscent Brook Park, and you can see the Reminiscent Brook Greenway Natural Trail is the easiest access to one of the two main systems that we have here to look at. So today we're going to be talking about the fossils that you're going to find, as well as the sediments that these are in and what kind of geology that we're talking about here. Now, I forgot to mention that my name is Rocky Sievers. Some of you guys know who I am. I am one of the geology faculty members at Stockton. I've been there for about 10 years now, and this is one of these things that has always been fun for me to do with my kids. It's something that is an excellent educational experience for people of all different kinds of ages. So you can see that this is the trailhead that leads us into the brook itself. Now, I'm going to kind of narrate things as we continue to walk down the trail. It's probably only about a quarter of a mile, roughly. But one of the important things we're also going to be kind of thinking about is the fact that we are going back as we are going to be looking through here. Now, you can obviously see that everything along here it's a pretty nice trail. But most importantly, it's a fairly easy way to experience something that you're not going to necessarily see if you're not looking and not aware of it and things. Now, this particular part of New Jersey is really well recognized for these fossils in particular. And one of the things that people don't realize is that New Jersey in general is a very important fossil locality. And in fact, one of the earliest dinosaur fossils was found in Haddonfield, and that's because of the fact that when you are looking at New Jersey, we are the southern and central half of the state are all part of what is called the coastal plain, and the coastal plain all the way from New York and just offshore of Massachusetts, all the way down around the coast of Florida and over through the Gulf of Mexico. And the coastal plain is all made of what we call unconsolidated sediments. And unconsolidated sediments is a fancy term for basically piles of sand, gravel, silt, and clay. So basically everything from very, very small sized particles of broken down rocks all the way up through gravel and pebble sized stuff. Imagine driving along a gravel road. And that's kind of the coarsest material that you're going to see. Now, I know there are a couple of you guys watching. Hopefully you guys can hear me. Anyone say yes or no? Let's see. Can you guys hear me at all? Coastal plain, like I said, runs for over 1,000 miles basically along the East Coast. And the plain is all the remnants of the sediments that have washed off of the east coast of North America approximately roughly 100 million. So what we're doing is we're literally going back in time as we are going through this area. And the important thing that you have to keep in mind is the fact that in order to really understand what is happening with the sediments that we're going to look at today, you have to think about what we call uniformitarianism. And this idea, good, I'm glad that you guys can hear me. The overall idea of uniformitarianism is that the processes that happen in the past are the same as what they are today. Or we can down and we can basically say that the events of today are the same as what they were in the past. Now, a couple of you guys are mentioning that the video is a little choppy. Can you see things, or does it look kind of irregular? Part of it is the fact that whenever you're out in the field, I think we don't necessarily get the greatest reception out here, but hopefully you guys can see things well enough. Now, this down here is the Reminiscent Brook, and we're going to go here in just a second. But I kind of wanted to point a couple of things out as we've been walking along. Now, some of you guys probably noticed that everything that we've been looking at and walking through is relatively flat. And this is not necessarily just related to the fossils that we're going to find in things, but when we are looking at river systems and stream systems like the Reminiscent Brook, they are always going to be cutting down through material, whether it's rocks, if you were up in North Jersey, say Sussex County kind of area, or whether they are cutting down through the sediments of the coastal plain, basically the southern half of the state. All of this is what we would call the floodplain of the Reminiscent Brook. Part of the important thing that you can basically see, there are no houses here, and that's because of the fact that in the event of a flooding event, this whole area is going to be inundated with water, theoretically. So one of the important things to keep in the back of your mind is the fact that rivers and stream systems are really some of the best areas where you can expose rocks and or sediments. And it's for this reason that a lot of the fossil collecting localities are along bodies of water. So is it just the video that's freezing or my voice that's freezing? Just real quickly. I did stop talking, but is it just the voice that's freezing? The video footage that's freezing? Okay, I'm back. Hopefully this isn't going to keep happening throughout the live stream here, but if it does, I know that we will just upload each of these as separate parts basically to Facebook for everybody to look at a later time. It's just a lot easier if everything is done live, obviously, since that's kind of the point, so that you guys can ask questions and things as we're going through this. But I realize that not everything is perfect with technology, and as a result, we just kind of have to accept the possibility that this may cut in and out. I know that a couple of my colleagues have had similar kinds of problems with their events doing the same things. So, let's see. Okay, so now that we're down at the stream bed, I wanted to point out a couple of the important things. Now, arguably one of the most important things to keep in mind when you're looking for these fossils and the sediments is the fact that all of the fossils are coming out of the sediment layers that are in here. They are not coming from very far upstream typically. They are typically only coming from a relatively short distance, and that's because of the fact that these fossils are quite commonly fairly fragile, and they will not survive a very lengthy journey along the riverbed here. Even though it looks quite peaceful, it still is quite damaging to most kinds of fossils that you would theoretically find in here. Hey Greg, can you hear me and or see my video, or is it too choppy? And are you guys able to actually see and or hear me, or is this all relatively completely lagging? Okay, good. I'm wondering if maybe it was just the kind of journey through the little woods there that causes the choppiness of the signal. Okay, so the important thing about all of this is the fact that the different sedimentary layers that are present on the coastal plain all have different kinds of characteristics to them. Now, the important thing about the coastal plain is that it all represents material that was originally either offshore of New Jersey, so basically meaning that the actual shoreline was further inland, or in some cases it represents areas of where the water level was significantly lower. And these are periods of time where we call transgressions, where water is going onto the continents and the land surface, and what we call regressions. And regressions are when the water is receding outwards and the shoreline is further into the ocean than where it would be under normal circumstances. And these kinds of variations are due to small scale and or large scale kinds of changes in our climate, which have happened over the entirety of human history, and frankly even of our entire planet's history. It's often thought that our climate is relatively stationary and doesn't change too much, except for the presence of global warming and or global climate change. But there are astronomical kinds of variations that cause significant changes in our planet's climate. And this causes the oceans to either get much further onshore, or they cause the water level in the oceans to go further out to shore. So what we find is that the coastal plain shows these trends regularly throughout the area. And this is true along the entirety of human history, even when they become solid rock, in the fact that we can find these kind of climate signals that change over time. Now, the coastal plain sediments in this particular area, there are of the greater Big Brook, Homedale area, are mostly due to three primary what we call formations. And formations are types of sediments or rocks that can be mapped out over a large area. And by large area, we're talking about, say, a 5 mile kind of square area, or larger than that. Now, formations can be a little bit complicated, but typically we name them for some particular locality, or they can get named for a particular person, but there are lots of different kinds of formation names. Now, the formations that are particularly relevant for the fossils that we find here in New Jersey are the Mount Laurel Formation. And the Mount Laurel Formation is obviously named for the town of Mount Laurel, down a little further south than here. And that's the kind of lowermost unit that we find in here. And what I mean by that is when you start to look at layers, sediments that are created at the surface get deposited in layers from the top, and then the lower down they go, the older they get. So if you were looking at this particular sediment outcrop here, which we'll get up close to here in a second, up here, these would be younger aged sediments than the ones that are down here. And these ones here would be younger than the ones that are down here at the base. That's all based on an idea that we call superposition. And this is one of the main tools that we use, or guiding principles for how we understand what we call geologic time. So when we look at the sediment formations in this area, the Mount Laurel formation is typically one of the oldest ones that we find in this particular area. The one that is a little bit older than that is what is called the Winona formation. And the Winona is only found in a few areas. Now, as you go upwards to younger kinds of sedimentary layers, the next one up that we typically find is what we call the Nava formation. And each of these different formations can have different amounts of fossils and different types of what we call sediment. Now, I'm going to start walking up a little closer to this outcrop here. Even though it's not rocks, we still call it an outcrop. Quickly clear this spider webs away. Now, you can see that there is a lot of plant overgrowth in here. There's a lot of moss, and that's because of the fact that in a lot of these cases, the sediments are fairly easy for things to grow through. If these were rocks, it would be much harder for lichen and moss and tree roots to penetrate their way down through it. So you can clearly see we have a big tree, and you'll note I'm not really that worried about it falling over or anything on me. But what you can basically look in here and see is there are changes in what the sediments look like. Notice how you have a very kind of black layer in here. And when I rub it, you can see it kind of leaves my finger fairly, what I would call muddy. And that's because of the fact that it's made of much finer sized kind of particles. This means smaller size. Now, if you look at the layer beneath it, and I'm going to kind of, you can see, this looks and fairly close to what you might imagine beach sand would look like. And that's because of the fact that this is sand that is not much different than what you would find if you were at LBI or Margate or Stone Harbor or any of the other coastal towns. This is a little bit finer than what you would probably find in the actual beach front itself, but most of the beaches have been artificially replenished with sand in it in most cases. So what you can notice though is the fact that they're all kind of mostly this kind of golden color, and that's because most of the sand here is made up of the mineral that we call quartz. And some of you guys probably know, and definitely know since you were my former students, know that quartz is made up of dominantly silicone and oxygen. This is where, if we were to be really desperate, they could mine and use this sand for making things like glass, and eventually into things like silicone chips for your computers and whatnot. So most of the sand that is in this particular area is not thick enough for it to be of any significant kind of use. Now, go back and forth, you'll notice there are some sandy layers in here. So even though we were in this unit that has more of this fine-grained stuff, you can see now it's gone into a sandy kind of unit. And then it goes back into this much finer grain type layer. And it goes back and forth. And that's because of the fact that as the coastline is changing, it does so relatively constantly. And you can see lots of changes from the finer grain, dark colored material. And the dark color commonly indicates that there is a lot of organic material in there. And by organic material, I may mean it could have had seaweed or seagrass, or it could have had plankton of other types that have all died, and they have added in their organic material. Now, Greg asked a good question of whether there's any green sand in here. And if you look at the water down in here, it's a little hard to really see. And there are some sections in here. What Greg is referring to as green sand is the presence of a particular mineral that glauconite. And I can see there is a little bit of glauconite right in here. Notice how this section has kind of a green color to it. That's not green because of the moss. There's moss down there. And I'm going to try and move out in the sunlight a little bit, or at least into a little brighter light. But this green sand is a mineral that we call glauconite. And glauconite is a type of clay mineral that for roughly 100 years or so was used and mined down in South Jersey predominantly. Some of you guys are probably more familiar with it as the Rowan Edelman fossil pit, but that used to be known as the green sand or inversand quarry. And the glauconite that was mined out of there and quarried out of there was predominantly used for water filtration, because glauconite goes in and takes some of the bad chemicals that we don't want to drink in our water supply, and it will neutralize it and take those in and release some of the more desirable kind of chemical components like potassium into the water, so it becomes suitable for drinking. And if you look down here, you can see all of this kind of green color in here. Not all of it, but a lot of it is that green sand. And that's because the two formations that I was talking about in particular, the Mount Laurel formation and more of the Nava Sink formation in particular, have fairly abundant amounts of this glauconite mineral. So it's not quite as abundant as it is if you get further to the south, but it is still fairly abundant in here. Now, all of these sediments were created and deposited roughly somewhere between a few kilometers offshore to maybe about 10 or 20 kilometers offshore. That would be, say, 5 miles roughly, so to speak. That's where we typically think the Mount Laurel formation probably was created. Probably a little bit closer in. The Nava Sink, we think, was probably a little bit deeper water, and as you go a little further up, it becomes a little shallower water, and that's because it goes through these climate cycles. So, and you can literally see some of these climate cycles represented by the changing of the color of these layers from the black or dark gray kind of color, where it's much finer, smaller sized material, into the kind of buff color, cream color, whatever you want to call it. I know my former students will probably make fun of me because I'm really bad with colors. But those represent sands that are a little bit closer to the shoreline, and they are going to be represented by mostly this quartz in here. Now, there are some other things that are present in here that I did want to kind of point out. And some of these things, if you look more closely at them, you'll see relatively solid chunks like this. And you'll notice, see how I can kind of release everything around this? Or if you look at this one right here, you'll notice it almost kind of breaks. And that's because of the fact that in a lot of these cases, these little solid kinds of chunks in here are representing either what we call phosphate pellets, where you have the element phosphorus and oxygen that have joined together and made what we call a phosphate mineral. And by the way, the main phosphate that they typically form is a mineral that we call apatite, and it's not spelled the same way of what you would have for your desire for lunch, although frankly most of us have already eaten lunch, but it's pronounced exactly the same way. And apatite is predominantly found as an important mineral in your bones. And so quite commonly we think of the presence of apatite and these phosphate nodules. No, this is not a pebble. This is actually a nodule. These things represent probably small amounts of bones that accumulated and then basically dissolved back up, and then they kind of reprecipitated and formed new amounts of these phosphate kind of minerals. So you'll find these scattered throughout all of these different areas. Now the other thing that you can also see in here are, there are some what we would call, I'm trying to find a good example that you can actually see. There are occasionally pebbles that you can find in here as well, particularly in some of the sandier layers. This particular outcrop does not have as many as one of the others I'll show you here in a second. But the main thing that I wanted to kind of point out here is the fact that all of these different sediments have the potential for having fossils in them. Now, what we typically find is that the main sequence of fossils come from kind of the uppermost part of the Mount Laurel formation, or they come from the bottom part of the Nava formation. So all of these sediments, the other thing I forgot to mention is the fact that all of these sediments were deposited about roughly 70 million years ago. And the Mount Laurel formation is thought to be starting kind of at about 74, 75 million years ago, and that it probably stopped about 69 or 70, and that shortly thereafter is when the Nava sink started to be deposited. Now, one of the other things that is also kind of important to point out is the fact that some of you are probably asking the question, well, why didn't I go to someplace in Mount Laurel or Medford or Marlton or that kind of area in order to show you the any kind of fossil collecting sites? And one of the big things that has always puzzled geologists and paleontologists and sedimentologists, those are the specific type of geologists who study sediments and sedimentary rocks, is why do they have such significant differences within the same formation? Because the Mount Laurel formation goes all the way down through the southernmost part of New Jersey over near Cumberland County and Gloucester County, and it goes over actually into Delaware as well. So one of the big questions is why this particular area in Holmdel and Big Brook, Colts Neck area, why is it very fossiliferous here versus, say, in the type locality of Mount Laurel, which would have been a lot easier for me to get to for my commute and things. And one of the things is we don't know why. We don't really have a very good explanation, other than that we think that maybe the Mount Laurel formation, as you go further south, is a little bit further offshore. And what I mean by that is it means that the water is a little bit deeper. And the reason why that becomes less desirable is the fossils that we find here in the greater Big Brook area are all mostly representing things that were living in the near shore kind of environment. And what I mean by that is we think of them as mostly being shark teeth. That's probably the most common kind of fossil that we tend to find up here. But we can also find occasionally dinosaur fossils. And they can also find basically the non-dinosaur dinosaur that we call the Mosasaur. And Mosasaur was basically the giant sea serpent, if you want to take the analogy of thinking about Loch Ness Monster. That's probably the greatest kind of analogy that people often give for the Mosasaur, except it lived it lived in saltwater kind of condition instead of the freshwater of Loch Ness. Now, I know while I may be making a joke on that, it gives you an idea that dinosaurs lived on land, and anything that was not living on land was not a dinosaur. So even though in the old days when you guys may have been kids, they may have said, oh yeah, the nice little swimming guy that looks like the images of Loch Ness was a dinosaur, well, that's not really correct. So they find these Mosasaur fossils in here. They also find turtle fossils. They find organisms that typically lived in relatively shallow water. And again, shallow is a relative term, but it means that we are talking about water that was not terribly deep. Now, all of the land-bearing kind of fossils, the dinosaurs, the turtles in some cases, there are also reports of occasionally you can find some crocodilian type fossils, although those are not usually present in this part of the coastal plain, but if you go further to the south and past Delaware, that's where you can find them in similar age kind of rocks. We think that quite commonly that the water depth was a little bit too deep, and so the fossils never really made it this far out, or they became broken down and shattered basically. And so we think that that is probably why, say, the Mount Laurel formation in Mount Laurel doesn't really have that many fossils. The other important thing that we also have to consider is, in order to accumulate fossils in any kind of abundance where people can collect them, you typically need some kind of mechanism to weather them out and release them into the water for them to accumulate enough for you to, say, find them. It's probably part of the reason why, if you were in Mount Laurel and you went digging in your yard, you might find a chance that you're going to find a fossil. But in order to concentrate them out of, say, a very low abundance, you need something like a river or stream system that is going to do that for you. And that's one of the things that is particularly nice about the Big Brook, the Reminiscent Brook, and all of the little side streams in this area is they are cutting down directly through these units of Mount Laurel Formation and the Nava Formation. So, key thing to think about when you're talking about all of this is the sediments are being deposited less than 5 miles offshore roughly, and these are representing typically fine-grained kind of sands. You can find some clay layers in there. You can find occasionally pebbles and things that made their way offshore. But typically speaking, it's dominantly sand-sized kind of material. And in here, I'm going to show you because I can't get all the way over to it because the water's getting a little deep. Here's an example of where you can see some gravel-sized material. See all those little pebbles in there? What that is telling us is that the water was moving a little bit more highly as those sediments were being deposited. If you contrast that with those black layers that we looked at back over there, that was a little bit finer grained, finer, smaller size. Means the water was a little bit deeper and or calm. Wasn't moving as much. Now, well, I know most people find the sediment stuff interesting. I know most people are probably more interested in actually finding fossils. And to that extent, I'm going to show you guys what you basically need to do if you're going to look for these fossils that we find here. Now, what you really need is you need one tool and one tool only. That one tool is some kind of a straining device that you can use to filter things out and get rid of the really small size material, all the sand, which we don't care about. Yeah, I know, Sorry, Greg. We don't care about that much about any of the green sand that is here. And we don't care about the quartz sand because it's not enough of it to make anything out of either. But we want to get rid of all of that material, and we want to focus on looking at the bigger particles. And the reason why is because the fossils are typically found wherever you see things like the gravel. And that's because of the fact that the fossils are bigger and they are a little bit more dense, and so they're going to settle in those particular areas. So you need something that's going to allow you to do that. Something like this. And you can see I even left the barcode, and let me pull that off. A simple colander. It's one of the reasons why I say that this is an activity that everybody can do from age 2 or 3 all the way to 99. When I've been here with my kids who are now age 11 and 12, they still love coming here. But every year that I come here, I'll see everybody from really old people all the way to toddlers. It's something that is not a particularly difficult thing to do. And like I said, nor do you need any kind of fancy equipment. This was a $1 colander. It's not a fancy one. It'll work because all I need to do is basically use it to get rid of the fine grained kind of material. Now, if you want to make it a little bit easier, you can also get a small shovel. Now, the one thing I will tell you is that you cannot use a big garden kind of shovel. There are some minor, by the way, you can hear kids in the background because people bring their kids out here all the time. But you can use a small hand trowel, so something that is smaller than the size of the colander, which you can see. If you can imagine the blade of your shovel, your hand shovel being probably no bigger than roughly the size of your hand, you can use a tool like that to help you scoop things up. Now, over the years, I've never found it necessary to have one, but everybody's different. Some people like to dig a little more. Some kids like digging more than anything else. But the basic idea is that you are going to use your colander, your mesh sieve. I typically come up here with some fancier sieves just because they're a little bit easier to handle. But all you really need is that, and you need the water to help wash away things. And so quite commonly, it really is just as simple as scooping some of the material up. And you can see, notice all of that fine grained material that is gone now. And now I'm just left with stuff that is what we would call gravel size or pebble size. And so now all you need to do is use your eyes and kind of comb through everything. The other thing I will also tell you is that a lot of kids, you will also enjoy just finding nice pieces of quartz and things. Because you will often find nice milky quartz in here. You can often find, occasionally you can find copper kind of minerals. I'll also point out one other thing in here when I get a better example of it. But typically what I always do is the easiest thing is to pull the biggest chunks out and then you just get rid of them because they're just in the way. But you can see all of this coarse stuff. All this coarse stuff in here, you can just kind of filter your way through. Now, and quite commonly within your first, typically your first 2 or 3, oh, I just passed one. Where'd it go? I found a shark tooth in here. 1 second, where'd it go? I just saw it. Where did it go? This is a little hard to do while I'm holding the phone.
Ooh, I found my first tooth.
And you will find everything from little teeny teeth all the way up through teeth that can be about an inch or a couple inches long at the very most. Most of the ones that you will find in here are relatively small. I'll show you some examples because I did bring a bag of some of my samples to show you some of the different types. But right here, I'm going to move off the water so I can set this down. So you can see, come on, this little tooth is the tip. Let's see if I can get it to focus. Shh. It's the tip of a little one. It was probably bigger than this. Well, it definitely was bigger than this before it broke. But at this point in time, I have gotten to the point where I don't keep usually the broken things. I only keep the ones that are significantly larger and are complete intact. Simply because of the fact that you get enough of these and you're going to not want them anymore because you're just going to find better ones. So again, you typically want to be looking for the kind of gravel-rich areas. And you can see I scooped up a decent amount. It's probably a little too much, frankly. And you just swirl it around so that you can get rid of all of the fine-grained stuff. And or plant fragments and stuff like that. You can see there's a blade of grass in there. That's the kind of stuff you don't want in here. So again, it's usually easiest to just kind of go through and pull some of the stuff out. Now, one of the other things that I will tell you is that in a lot of cases, if you find something that doesn't look nice and rounded, yeah, that's part of one.
I found a scary one.
So, I just found a small fossil. This is one of the fish fossils, and I'm going to try to show. Shh. One of the kids that is here found this and showed it to me. But this is one of the fish teeth that you can find. And one of the ways that you can kind of recognize it is these are grinding fish, and they will typically have a concave inside part in here. And it's a little hard to see all the details. Let's get it out in the light a little better. But see how it's kind of concave on the inside in there? This particular type of fish was kind of a relatively flat fish. They will form these kind of rounded things that have these hollowed in sections. So again, usually you just want to kind of go through, and it's easiest to just kind of go away, bug. To go through, and you will find it's relatively easy to just kind of grab a handful of it, glance through it, and get rid of it if you don't find anything. Some people like using a more spaced out mesh to get rid of the material a little more efficiently. Some people like to maybe look a little more carefully and maybe find some of the smaller kinds of fragments in here. Again, I probably got a little bit too much. Sometimes, by the way, you can literally just walk on the sand. Yes. You can literally walk on the sand and find fragments. Oh, everyone see the shark tooth right there? Smack dab in the middle. Let me quickly clean off my hand, and then I'll show you this one a little closer up. But that's one of the shark teeth that you can typically find. This looks like it is, and again, it's hard to zoom in enough on this without making it too sparse. And now I'm moving into the sunlight a little bit. You can see this one is probably about a centimeter long or so. So this is a relatively medium-sized one for this particular area. Now, there are several different types of shark teeth that you can find up here. One of them is there are several different types of shark species that are represented in here. And some of them are relatively hard to tell apart, and some of them are relatively easy to tell apart. But typically one of the classic ways that you can look through your sediment in your gravel size material is anything that's not particularly rounded. There's oftentimes a decent chance that you are looking at some kind of fossil. And sometimes they are not as obvious as shark teeth, like the grinding teeth fossil that I just showed you a second ago. But again, people can spend all day doing this. Some people have the patience to do it for an hour. It really just depends on what you're going to look for and what you're finding. Because some of it is really luck. Some of it really is just kind of luck of the draw, frankly. There have been times where I've come here and I have gathered up literally a whole Ziploc bag. And then there have been times where I've gone through and found only a handful and have filled up. Nope, there's another small one. Anything, by the way, that's pointy is typically going to be a shark tooth. There are a couple of other types of teeth that you can find in here. And I'll show you a couple of examples of that. But again, typically the easiest thing is just to kind of move your hand around. Again, I probably gathered a bit too much in here. Just, it's a little more efficient to have less in there. And I've probably already picked out any of the ones that were in there, but I mean, considering the fact that I just found two in one batch, that's not bad. But I mean, sometimes I've pulled 4 or 5 out of one particular pocket. It really is just a little bit of trial and error, so to speak. Now, I did bring a small bag of some of my samples over the years that I've collected that I can show you guys some of the different kinds of species of shark teeth that you're going to find. So, I'm going to move over here for 1 second so that I can pull some of these out. And plus I can sit down. No, I don't want to rotate my phone. So, one of the types of shark teeth that probably the most common type of shark teeth that you will find in here are what we call the, let's see, where is it? Trying to grab through all my stuff, are the goblin shark teeth. And the goblin shark teeth, they're typically defined by the presence of these linear, what we call striations, that run the length of the tooth and will penetrate down into the root of them. They're relatively pointy quite commonly, and you can see this one is slightly broken off. But quite commonly, that's what they will look like. Another one of the common types, there are 2 different varieties of these, 2 different species. But these are what we call crow shark. That's the specific variety, and there are 2 or 3. Oh, okay, good. It came back. But there are a couple of different species of these crow shark teeth. You'll notice the shape of it is completely different than the goblin shark tooth or what we call the angel shark tooth, and I'm trying to find another one of those, or what we call the mackerel shark tooth. So that's another variety, another example of this crow shark tooth. And that one, the two at the top are examples of these goblin shark teeth. You can also find the variety that we call mackerel shark tooth, and I'm trying to get it out of my bag. Which is typically smaller because they were a smaller species of shark. But this one on the bottom here is one of the different types of mackerel sharks you find in here. The other kind of fish fossil that you can often find is this guy, which is a Hadrotus type of fish. And they were similar species to the, they're kind of similar to a flat kind of fish. They're not quite like flounder, but they're similar types. I think they're in the overall family, if I remember specifically off of the top of my head. This is the one that was the picture on the front header for this particular event here. They will commonly look more hook-shaped than the shark teeth that you will find. These are also less common than the shark teeth than you're going to find. Now, you can also find other kinds of fossils in here. You can find vertebrate of the fossils. You can find plant fossils. This is an example of a more modern seed from about 30 million years ago instead of the 70 million years ago. This has been washed in from much more recent kind of activity. But you can find seeds in here, for example. Again, indicative of the plants. You can find other kinds of fish fossils. This is a tooth from what the group of fish that we call sawfish. If you've ever seen them, they're kind of flat. They're sort of more related to rays than they are to sharks. These would have been protruding from their jaw, and I have one other of those. Oh, actually, no, I grabbed the salmon. There was also a giant salmon type of fish that was present in this time period too. This one is broken off, but it also doesn't have the same kind of sharpness that on the sides. It's more of a rounded kind of shape to it compared with the shark kind of fossils, or even the sawfish here. Because here's the sawfish that you can see. Again, it has relatively sharp kinds of sides on it compared with this much more rounded shape kind of structure to it. In most cases, anything that looks slightly irregular or unusual, there's a pretty good chance that you're dealing with a fossil of some type. This, for example, is a fossil of some kind of cartilage. Again, it's the cartilage of some type of shark species or ray. You really can't specify any more than this. My colleague and Stockton alumnus Dana Earhart is one of the masters of identifying this stuff. He is at the New Jersey Science Museum in Trenton, and he told me that, yeah, it's cartilage, but you can't really tell much more than that. He's the one, amongst many other people, that are much more efficient at this than I am. But anything that looks kind of unusual, there's a decent chance that you might be looking at some kind of fossilized material. And again, all it takes is literally, you can see a colander. Yeah, that's my fancier sieve pan that I typically bring up when I do it here. But overall, it's a great kind of activity for people of all different ages. Again, I've taken my kids here since they were about 7 years old or so, and I probably could have. They just like playing in the water. They'll enjoy looking at the sand. Again, you'll find half the kids want to pick out quartz pebbles. Everybody can find something to do here, and they get some kind of hands science kind of activity. And basically what they are is they're doing budding geology. So I didn't have anything else I was going to add. Hopefully you guys will find the opportunity to come up here to either the Reminiscent Brook, or you can go to the Big Brook Preserve. The actual fossil location for that is most easily accessible off of the Boundary Road. There's a little parking area up there. The main entrance to Big Brook Park is not quite as efficient for actually finding the fossils. But again, it's a relatively easy activity to do with anybody from toddlers all the way through college age. If you're an adult and want to do something outdoors and have some fun outdoors and collect some fossils. So if anyone has any questions, I'm happy to answer them. And if not, then hopefully, like I said, you've come away from this and learning something and gotten a better appreciation for geology. I will also tell you that in 2 weeks I will be doing another trip, another live streaming event where we will go and look at some mineral sample locations, one single location, and learn about what minerals are in much greater detail. So, any questions? If not, I will go ahead and sign off. Enjoy, everybody.